lessons, we've been looking at ways to solve systems of linear equations. We're now going to shift and work with systems of linear inequalities as a means to solving problems that are defined by linear programming. In a linear programming problem, we use two or more linear inequalities to define a region that contains all of the possible answers for our situation, and then we choose an answer that most nearly fits what we want. We're going to start with just graphing some linear inequalities into variables. So here's our first one. 3x minus 2y less than or equal to 6. This inequality describes what we call a half plane. It's going to be a line and then either all the points above the line or all the points below the line. We're going to begin by solving this inequality for y and graphing that line. So I'm going to subtract 3x from both sides. And then divide by -2. Remembering that when I divide by a negative number, I have to flip the inequality over. And now I'm going to graph the line that forms the edge of this. My y-intercept is -3. So I'll come down here to -3. And then my slope is 3/2. So up 3/2, up 3/2. And I just draw the line. Okay, so this is my border line. And because we say greater than or equal to, we know that the border line is part of the region. And we just need to find the half plane where y is greater than this or above the line, which would be this area here. Pause your video now and work on checkpoint 1. In this problem, we'll graph an inequality that does not include the or equal to part. Here we've got x plus 4y is less than 4. Once again, we're going to solve for y. So I'm going to have 4y less than 4 minus x, and then divide everything by 4. So I have y less than 1 minus 1/4 x. So once again, I look for my y-intercept, which would be 1. And then I have a slope of -1/4. So down 1/4. Back 4 and up 1. And I need to draw a dashed line for this one. Because the line itself is not part of my solution. And we see y is less than. So we're going to shade below the line. Pause your video now and work on checkpoint 2. Here's another inequality. 5y minus 2x less than or equal to 10. Same as before. And now we're going to divide by 5. In your book, they changed 2 over 5 to a decimal. I actually prefer to leave it as a fraction for my slope. And so now I have y is less than 2 plus 2/5 x. So here's my y-intercept at 2. And my slope is 2/5, so up 2 over 5. Down 2, back 5. Solid line. And y is less than this. So we shade down here. Pause your video now and work on checkpoint 3. Now we're going to look at a couple of special cases where we have just one variable in the inequality. For instance, if I have y is greater than or equal to 2, this is a horizontal line at y equals 2, and it's solid. And we're greater than, so up above this line. In a similar way, if I have x less than or equal to -1, I know x equals -1 is a solid line, vertical, and less than would be in this area. So that's graphing inequalities where the border is either a vertical or a horizontal line. So pause your video now and work on checkpoint 4. In this example, I'm going to show you an alternative way to graph your line and to decide which side of the line should be shaded. We're going to start with 4y minus 2x greater than or equal to 6. And this method is called graphing by intercepts. So what I'm going to do is start off by letting y equal 0. So if y is 0, this whole part is gone, and I have negative 2x greater than or equal to 6. And then I divide by negative 2. So I have x less than or equal to negative 3. And what I'm really interested in here is the part where x equals negative 3. Because that is my intercept. So here's x equals negative 3 when y equals 0. Now I'm going to let x equal 0. So I have the same inequality. Now this portion is going to be 0, so I have 4y greater than or equal to 6, and I just divide by 4. I've got y greater than or equal to 3 over 2. So when x is 0, I know I'm on the y-axis, so I come up here to 3 over 2. That's my other point. And I'm going to draw a line connecting those 2 points. This is called graphing by intercepts. You find that x-intercept and the y-intercept and connect the dots. Now another thing I can do is, since I did not solve this for y specifically, you might be a little confused about, well, which side should I shade? And to decide that, we're going to pick some test points. If the line does not go through 0, 0, 0, 0 is always a nice test point because it makes our math really easy. If x and y are both 0 at the same time, is this a true statement? Is 0 greater than or equal to 6? That's not true. So that means we should not shade here. Just to be sure, let's use -2, 2. And if I put that in here, I'm going to have 4 times 2 minus 2 times -2. And I want to know, is that greater than or equal to 6? Well, this is 8. And the negative is going to be plus 4. Greater than or equal to 6? Yes, it is. So that tells me that I should shade up here where my test point is. But just another technique for graphing inequalities. Since my y-intercept is at 12, so I'm going to go up by 3s, 3, 6, 9, 12. And my slope is -3. I can still count that down 3 and over 1, like that, and use my solid line. Okay, I'm going to use the test point. If x and y are both 0, all of this is 0. Is that less than 12? It is. Because I'm doing a system, I'm not going to do a lot of shading just yet. I will draw arrows to show that that's the part that should be shaded. Now I'm going to look at my other inequality. X less than or equal to 2y. And I could divide that by 2 and have 1/2 x less than or equal to y. So there's no y-intercept except the origin, and my slope is 1/2, so up 1 over 2, up 1 over 2, like so. Now I cannot use 0, 0 for my test point because it goes right through there, but I could use 1, 1, and then I would have 1/2 of 1, which is 1/2. Is that less than 1? Yes, it is. So I know now that I have to shade this direction. I'm only shading here because this is also a boundary point. So the solution for this system of inequalities is this area. Because it contains parts of the regions for both inequalities. So pause your video now and work on checkpoint 5. When we graph multiple inequalities on the same coordinate grid, the area where all the inequalities overlap is called the feasible region, because this region contains all the points that are solutions for all the inequalities. Let's practice writing or graphing a feasible region. Okay, I'm going to start with this inequality. And I'm going to graph by intercepts because 2 and 5 are both factors of 10. So if I let x equal 0, then then y would have to be -2. And we're going to let each unit represent each square. For this problem, we're going to let each square represent 2 units. So when x was 0, y was 2, and that'll be right there. Now when y is 0, x is going to be 5. So we'll put a point right here. And there's our line. If I use my test point 0, 0, 0 is less than 10, that's true. So I know I'm going to shade up this direction. Our next inequality is x plus 2y less than or equal to 8. Well, if I let x be 0, then y would be 4. So 2, 4. If I let y be 0, then x would be 8. 2, 4, 6, 8. Put another point here. Once again, I use 0, 0 for my test point. 0 plus 0 is less than 8. So we'll be shading this direction. So now we have this kind of triangular region that satisfies both inequalities. We have 2 more to go, and these are inequalities you see very commonly in real-world problems, because very often we don't want x or y to be negative numbers. If we're talking about real-life objects, we don't want negative money or negative time or anything like that. So x greater than or equal to 0 is just going to go this way. And y greater than or equal to 0 will be above this line. So it's kind of a confusing mishmash here. But this ends up being my feasible region. And I'm going to go ahead and erase all the things that are not in my feasible region. So you can see it's this quadrilateral shape is my feasible region. So pause the video now and work on checkpoint 6. Let's graph another feasible region. Here I have 5y minus 2x less than or equal to 10. So again, if y were to equal 0, then x would be -5. And if x were equal to 0, then y would be 2. So let's draw our grid. And we'll go back to 1 square per unit. So I have this point 0, 2. I have this other point -5, 0. Out here. There's my line. 0, 0 does fit this. So we're going this way. And now I have x greater than or equal to 3. So we'll just draw a solid line at 3 greater than would go to the right. And then y greater than or equal to 2. So up here, and that would go this way. And so I have this region that is my feasible region, but you might notice there's no side over here. So this region is not bounded, but it still is a feasible region for this set of inequalities. For those of you who are thinking, yeah, but how would I ever use this? Here's your chance. Let's look at a practical application. In 2017, the T. Rowe Price tax-free high-yield fund paid a 3-year return of 5%, and the BlackRock fund, BlackRock California Municipal Opportunities Fund, paid a 3-year return of 4%. Sherry would like to invest up to $75,000 and obtain at least $2,500 in interest over a 3-year period. Write a system of inequalities expressing these conditions and then graph the feasible region. So let's talk first about the money that's going to be invested. Let's say X is going to represent T. Rowe Price, and Y is going to represent BlackRock California Municipal Opportunities. Altogether, she wants to invest $75,000. So I've got X plus Y greater than or equal to $75,000. That's all the money she's got to invest right now. Okay. We'd like to have at least $2,500 in interest. So the T. Rowe Price is earning 5%, so 0.05 X plus 0.04 Y for the other fund. We want that to be greater than or equal to $2,500. To make this a little easier, I'm going to multiply this inequality by 100. So I have 5x plus 4y greater than or equal to $250,000. Or $250,000. Okay, so now these are a little more in sync with each other. So now these are a little more in sync with each other in the same range of numbers. So let's get rid of this and figure out how we're going to graph this. If I were to change this into a slope-intercept form, I'd have y greater than or equal to negative x plus 75,000. Down here, I can move the 5x over. And now we'll rewrite that divide by 4. And I got y greater than or equal to 250,000 divided by 4 is 62,500. Minus 5 over 4x. Okay, clearly our y-intercepts are quite large, so I'm going to make these units on the y-axis 10,000 up this way. We'll just do the same thing on the other one. Okay, so y greater than or equal to 62,500. So 10, 20, 30, 40, 50, 62,500 would be there. My slope is -5/4. So down 1, 2, 3, 4, 5. 1, 2, 3, 4. I can still count the slope that way as long as I'm going to use the same scale. So this is 10, 20, 30, 40, $50,000. And I said that I wanted y to be greater than that. So I'm going to shade y this direction. And going back to my first inequality, $75,000. So this was 62.5. There's 70. There's 75. And we've got a slope of -1. So we're going to come down here and also be at 60.75. And I wrote this wrong. My x and y have to be less than $75,000. That's all the money I've got. And what that means is that here we're going to shade this direction. So now this shaded area, this feasible region, shows me all the ways that I could split up that money to meet my goals. So pause your video now and work on the last checkpoint and then move on to your homework assignment.